Section 1.8 has to do with exploring transformations, and this should be a review from geometry. We're going to look at translations and reflections, so we want to be able to apply translation or reflection to a point or sets of points. A transformation is a change in the position, the size, or shape of a figure, and a translation is a transformation that slides a figure on a coordinate plane, either left, right, up, or down. The location of the figure changes, but the size and the shape remain the same. Now, you're going to have to change the word here. It looks like when you are performing, not preforming, a translation, you use addition or subtraction. A reflection is a transformation that flips a figure across a line called the line of reflection. Again, the size and shape remain the same. And it looks like I just copied and pasted this down here, so we're going to have to make a couple changes here. When you are performing this should be changed to reflection, you take the opposite. So let's do a couple of examples down here. When you're translating points, the operation is you either add or subtract. So here's my original point, 1, -3. I'm going to translate that point 3 units to the right, and when I do that, if I'm going to the right, the x is being changed. So that means I have to add that 3 to the x coordinate. The y coordinate stays the same, so I end up with the point 4, -3. When you're moving left or right, you're moving horizontal, and the x coordinate changes. So let's go ahead and translate the point down now. So our original point is going to be at -3, 2, and we want to move down 5 units. So the way that we can show that, if we're moving down, we're moving along the y-axis. So that means the 5 has to be subtracted, since we're moving down, from the y-coordinate. So we say x stays the same, take the y-coordinate, subtract 5, and we end up with a -3, -3. So when you're moving up or down, which is vertical, the y-coordinate changes. Let's look at what happens with a reflection. We take the opposite. So if we plot the point 1, 3, and we want to take, we plotted the point to start with of 1, -3, which is here, and we want to take the opposite of the y-coordinate. Well, when we do that, it turns into 1, 3. So look what happens. The point is reflecting across the y-axis, or the x-axis, sorry. So if we flip across the x-axis, we take the opposite of y. So the point flipped over the x-axis. So when you are reflecting over the x-axis, the x-coordinate stays the same like it did here, 1 and 1, and the y-coordinate changes. It went from a -3 to a +3. And then let's take the opposite of the x-coordinate. So we're going to have the point -3, 2. Here's -3, 2. That's the one we're starting with. And now we're going to take the opposite of the x-coordinate. So that's going to give us a +3, 2. Well, what happens there is it flips or reflects over the y-axis. When we took the opposite of x, it reflected across the y. So the point flipped or reflected across over the y-axis. So when you reflect over the y-axis, the y-coordinate stays the same, and the x-coordinate changes. Okay, so keep those things in mind. All right, if we're graphing transformations of functions, you use a table of x and y values. You include a column for the transformations. If the transformation affects the x-coordinate, add the transformation column to the left side. If it affects the y-coordinate, add the transformation column to the right side. You want to choose enough points on the function to give you the shape of the graph, and always graph critical points. And that's where the graph of the function changes. You want to include angles and curves and points that give you, and I'm putting final in quotes because the graphs could go off into infinity, but we want the final direction of the function. So I'll show you what I mean right here on this example. If we want to translate vertically the function 1 unit up and graph it, we're going to add. Okay, which coordinate stays the same if we're going vertical? The x-coordinate stays the same, and the y-coordinate changes. And then it looks like we need to cross this off here. Which coordinate changes? That's the y-coordinate. Okay, so here is our graph. And I've just picked up some points here for you so you can just write them down. Negative 4, 4 is here, negative 1, 1, 1, 1, and 3, negative 3. So we're going to put those in our table, and we want to move 1 unit up, so that affects the y. That's why you're going to make your change over in this column here. And I do want you to do these columns because when we get into more complicated functions and more complicated transformations, we're going to need to do this table. So what you do now is once you have this, now you're going to cross off the extra one. So this, we want this x and the y changed from this column to this column. So now our ordered pairs are negative 4, 5, negative 1, 2, 1, 2, and 3, negative 2. So you can go ahead and graph that function. Okay, now we're going to reflect the function over the x-axis and graph it. Okay, the operation we're going to take is the opposite. And because we're reflecting across the x-axis, x stays the same. So x-axis, x stays the same. And the y is going to go to the opposite. All right, so we're reflecting across the x-axis. So again, we're going to use these same points, and I must not have been paying attention too well when I typed this up. So we need to cross off this column here. Because the x is staying the same, we need to add y on the other side. So here we have our same points, which were for negative 4, 4, negative 1, 1, 1, 1, and 3, negative 3. And on the right-hand side, since our x is going to stay the same, we're taking the opposite of y. We'll just show the negative y here. So the y is going to go to the opposite on each one of these. And now we're going to cross off this column because we don't want to accidentally just graph the same thing again or graph the wrong combination. So let's just cross off this column right here. And that will leave us with our points negative 4, negative 4. So let's go ahead and graph that. And then negative 1, negative 1, 1, negative 1, and 3, 3. Okay, so I'm just going to make this dash so we can kind of tell the difference between the two of them. We'll just graph it this way, and then it'll go up. Okay, so if you were to fold your paper all across that x-axis, you would see that this function reflected across the x-axis when we took the opposite of y. Okay, now it's your turn. I have 2 transformations for you to do. Make sure you use the 2 tables that are provided. And then this one you want to translate horizontally. So actually this table is, let's just change this to be, try to think of how to change this without crossing the whole thing off. We want to change the x because it's horizontal. So let's just draw one underneath here. We'll make the x change. Here's the x and y here. And we're reflecting across the x-axis, so the x stays the same. And the y goes to the opposite. And you can just fill it in down there instead of using these tables here.